So welcome to part 2 of this. So remember, we have to show that we have to prove this equation u over theta square equal to minus f bracket 1 over u over m a square r square. We are proving this. Initially, the first question wasn't correct because I told you that second derivative is an acceleration and it has to be due to a function. It is the gradient upon the gradient. Finding the gradient of the gradient. And you know that gradient m is equal to the y, the x, which is equal to y2 minus y1 over x2 minus x1. That is the change, right? So I showed you the limit in the first video. You can check it. So going back to this, we want to get, remember that in Newton's second law, we have F equals ma. Now we are getting this in polar vector form. Getting acceleration in polar vector form is the second law of Newton. Now getting this in polar vector form, we have, so we do for A, vector polar position of acceleration is r dot dot minus r theta raised to the power 2 bracket r. This is standard after finding plus r theta dot minus 2 r dot theta dot angular displacement. You close angular displacement. Now substituting it back here, you have r angle of r equal to f of r, which is the function, f of r, which is the function, equal to m, which is the mass. Then take everything here. Let's call this equation 3, but we have other equations there. Substitute this into this. We have r dot dot minus r dot raised to the power 2 angle of r, that's the radial position, plus r theta dot minus 2 r dot theta dot angular displacement. Remember from calculus, r dot equals the r over the t, and theta dot equals the r over the theta. Then r dot dot equals r, that's second derivative, which is the acceleration. Then theta dot dot equals d square r, d square theta over the theta square. So you see how that is going. Taking them by parts, let's take the angular displacement part. We have from this equation, we take the whole of this equation. We have theta bracket r theta dot minus 2 r dot theta dot equal to 0. Let's say this is equation 4. Now this cancels this. You have r theta dot minus 2 r dot theta dot equal to 0. Now we're going to do a breakdown there. Doing a breakdown, you're taking d over dt. We have r theta dot equal to 0. Take your time to do this breakdown. So when we do this breakdown, let's assume that r theta dot equal to a constant h, which is a constant. So going back to the beginning, remember we are still solving for this question. Okay, let's see something for this question. Okay, is equal to a constant. So remember that last equation, we have from taking the part, because we just finished for the part of the angular displacement, and we resolve that r theta dot equal to a constant. So when you're done with that, we resolve that. We want to solve for the other side. M equals r dot dot minus r theta dot squared equals to angular is equal to f of r, which is equal to r. So this definitely so when we're analyzing them, we take them like not taking them individually. You have m equal to r dot dot minus r theta dot squared equal to f of r. Now you see that it's making sense. It's now this equation looks like this. Ma equals to f, which is what? Second law. Second law of Newton. Right? Now breaking that further, what we have to say, okay, substituting what we have for back to the equation. I was just using this as an illustration. We are taking back here. We have divide both sides by m. We have arrow dot dot minus arrow theta dot squared equals to f arrow equal to m. You see, I'm trying to make the acceleration part, because this part is the acceleration part in the angular displacement. You can call it acceleration in the radii position. So this side is the acceleration in the radii position. Taking this to be like that, let's say, remember that there was a place we said arrow theta dot equals to h, which is a constant. So here, let us assume that r equals to 1 over u equal to u. So now, since we're assuming, wherever we see that, we substitute that. Also, taking this parameter, substituting it above, you have 1 over u squared theta equals to h is equals to h u theta. Let's take this as equation 7. So taking that as equation 7, we want to solve for to get r dot, which is what? Equal to the r over the t. The r over t equal to the r over the theta dot the theta over the t. That's the way to break it down. And breaking it down, we have the theta 1 over u dot the theta dot. So breaking it down further, we have further breakdown to be 1 over u squared dot the u over the theta dot. Remember what theta is. Theta dot is. So let's come further to get the final equation equal to 1 over u squared dot the u over the theta dot hu equals minus h du over the theta. So we stop here. See you in part 3. Please hit the subscribe button if you're just joining. Hit the subscribe button and stay tuned for part 3.